Hello everyone. This is the video lecture for College Algebra Math 1314 section P.2. So we're still in the chapter P sections, P for preliminary. So we're going to be seeing a lot of review content here. In P.2 in particular, we're going to be doing powers and exponents and stuff like that. So, and of course, simplifying and all that kind of good stuff. The very first three questions are, I would say, like rapid fire here. They're really fast and easy, but at the same time, I want to make sure that we cover it so that you could see what's going on with each of these smaller topics here. Could you just put this into a calculator? Yes, but I mean, we want to do a balance here. I want to teach you a little bit about what's going on behind the scenes as well. So the 6 power is actually going to be distributing to both of those terms, I guess you could say, each component. And so how many minus signs do we have? Well, we have 6. And you know the rule that 2 negatives make a positive. So let me list this out. We got 1, 2, 3, 4, 5, 6 negatives. And then we got a number after that, which we'll figure that out here in a minute. Well, these 2 cancel, those 2 cancel, those 2 cancel. And so what we're actually left with in the end is going to be a positive answer. And so that's why I said distribute in a way. I'm not really distributing, but I wanted to show that effect. And so our number that we're going to be looking at is 2 to the 6th. And if you don't know your powers of 2s, then definitely just use a calculator, of course. But we got 2, 4, 8, 16, 32, 64. I just was counting on my fingers. So a positive 64 is the answer. Don't put a plus sign here. I don't think that the program will kind of like that. But 64, good enough. There you go. And yes, of course, you can use your calculator. This one's a little different here. Notice that I said, oh, we'll power 4. And so what I'm getting out of this actually is going to be a negative answer. Because what's going on here is that it's the 1 that has the power 4. That minus sign does not have it. See, here it does, here it doesn't. And so parentheses is important, as you can see. If you don't put your parentheses here with the 6 power, you're going to end up with a negative or something like that, and that's not the answer. But here, it is important to have a negative as your answer. So you'll definitely have 1 negative, that's it. And then what's 1 to the 4th? Well, 1 times 1 times 1 times 1 is a 1. And so it's going to be a negative 1 for your final answer there. I just thought this was a cool problem here. It's very similar to the last one, but now with a 0 power. Again, though, notice that the 0 applies only to the 4. So, as you know, anything to the 0 power is equal to 1. So 4 to the 0 is a 1, 6 to the 0 is a 1, 100 to the 0 is equal to 1, everything's equal to 1, that's fine. But that 0 did not apply to that negative here, and so you're forced to keep and retain that negative sign. And then, of course, your number is a 1. So, pretty interesting problems there. Number 4 and 5 I also grouped together because I thought they're very similar. They definitely have different actions, but they're the smaller steps so that we can get to the bigger ones here in a few minutes. So what we're doing here is multiplying your bases, and so what we're going to do is we add the powers. Multiply your bases means that you're going to add your powers, and so what you actually get here is x to the power of 7 plus 6. And so I'm just simply adding them in the top there. And of course, that's pretty simple math here. It's 13, and so we got x to the 13 power, and that's your answer. You're done. Nothing else. Type it just like that in the program. Okay? That's it. Now let's work on this guy. Here's another new rule. It's when you have powers of powers, they multiply. Powers of powers, they multiply. I'm trying to remind you of these things. So again, multiply your bases, you add the powers. Powers of powers, multiply. It's kind of like, I wouldn't say it's like a song, but it's something that you're remembering. And it, like once I start to say it, powers of powers, what do they do? And you say, they multiply. And so that way you kind of like fill it in. It's just good for the human brain to do this sort of thing. And so I'm going to multiply these two numbers together, and what it looks like, I guess, is, I don't know, something like that. But really, we know what they're going to be when you multiply them. you're going to get a negative 28. Now, this is the tricky part. Are you done? Well, yes. No. Here's the thing. If you type that into the program, it is likely that you get it wrong. So why are you wrong? And what I would say, as I've said on the other video that we had, is that if you don't understand the format that they're wanting you to put it in, just go ahead and get it wrong 3 times, see what they have as their answer, and now next time you'll understand what they're actually meaning. And so they have words beside it that says something kind of like positive exponents. And what we have is a negative exponent. So they're not going to like this. We have to do something else to it in order to make it work for the program. And so what we're going to have to do actually is say, it's a negative power, and what that means is that it's actually in the denominator. Okay, so that's just a rule. It's just a rule. Just kind of like powers of powers multiply. Same thing here. If you got a negative in your power, a negative exponent is actually in the denominator. And this is what they're wanting. That's the answer that the program wants. So it should work now. Okay, so we're learning how to type it in. We're learning what is expected of us. And this problem here, there's no way you could do that on a calculator. So it's a good thing that we're doing this together. Okay, so number 6. I have some, I guess, 2 numbers here that are divided. And it's kind of weird because they got different exponents and they don't just cancel. I don't know what to do. It's kind of weird, right? Well, we're going to use that same property we had just a couple seconds ago. Well, on the previous one here. If you have a negative power, it's in a fraction, or you flip it, or something like that. I guess I use the word flip a lot of times, denominator. Here, though, it's actually in the denominator already, which is kind of weird. And so what we're going to have to do, I like to use the word flip. And so see how this was in the top, and now I took these and I flipped them, right? See, I flipped them. And that works now. If we're in the bottom here, what we could do is, because it has a negative, we could flip it into the top. And so that what we actually get is times the x to the 3rd power. And like, there's your denominator, I guess, if you need one. It's just another way to write it more simply. Of course, there's a formula to do this, and we could simply, I'm going to show you another way to do it, but this is just one way that we can easily see, I don't know, you could flip the negatives into the numerator. And so, multiplying your bases, that means that you're adding your powers. So x to the 10th, and you're done. The end. Nothing else. So there is another way you can do this problem. If you have 2 values that are, I don't know, I already gave it away, divided by one another, you could subtract their powers. I don't really like to use this rule very often, just me personally. 2 negatives make a positive, of course, and then you can get this guy here. So there is a way, of course, to do it directly, but I think that the point here was that you want to flip that into the numerator. You want to use that negative exponent to your advantage. So just keep on cruising. Another problem. I actually modified this problem a little bit from what was already there on a homework program. I thought it was boring, so I wanted to add a little bit more flavor to it. And so this is going to be more difficult than the one that you have. But still, though, I think that it's cool to kind of explore and see how this will work. And so we have a 3rd power, but that applies to everything. That means that negative sign, the 3, and this x squared here in the bottom. And so we got a lot of things going on. And what I want to do is break down each component separately and see what we're going to get. So then I actually have 3 negatives. And I'm just going to show you on the side here, 3 negatives. Well, 2 cancel, leaves 1 behind. And so we have a negative answer for sure. Like, you can go into the box in the program and just type negative. You're already halfway there. We just have to find out what the rest is. Okay, so this 3 to the 3rd power, okay? We got 3 to the 3rd power. That's some kind of number. We'll figure that out in here in a second. And then we got x squared to the 3rd power. And so this 3 to the third, if you know your threes, it's 3, 9, 27. But you could definitely use a calculator if you want to do that. That's totally fine. Notice here we got powers of powers, and they what? They multiply. And so then what we have is actually a 2 times 3 makes a 6. And so that's going to be the answer there. You're actually done. Because they say that you want those positive exponents and whatnot, notice that your number here in the bottom, I know technically if you were to flip it, it would be a negative and all that, but that's not the point here. When you're looking at this problem right here, the answer, do you have a negative exponent? Not a problem, not an answer. Do you have a negative up here in the exponent? And the answer is no. You actually have a positive value. That's a positive 6 if you're just straight up looking right here. Positive 6. So you're good. Do you have a positive exponent? Yes. So again, if you're confused about how you want to actually put the answer for this one, get it wrong a couple times, see what they have, and then you can go back and then you can, when you're doing the problem over again with a new set of numbers, you understand where to stop. Where do I stop? How do I know I've gone far enough? How do I know that I should, stop doing what I'm doing? Anyways. All right. Number 8. So this one looks pretty big, and I like those. I like when they look big and like, oh, they're so difficult. But in the end, it's not too bad. What's going on is that they're multiplying, and what we're going to do here is multiply like terms together, because everything is multiplied here. You don't have to do anything like foiling. I know that you're thinking foil. That's definitely not this problem. If you don't know what foiling is, we'll get to that eventually. That's not right now. But my point is there's a lot going on, but it's not too bad. I'm going to combine like terms, kinda. I'm going to get my numbers together. I'm going to get my x's together. I'm going to get my y's together, and that's technically a y to the 1. And so let's just look at the numbers. Notice that what we have is a -4 and a -5, and we're multiplying them together. Well, what do you get there? 2 negatives make a positive 20. Okay. Now let's look at the x's. So I got an x cubed, and I'm multiplying it by the x to the 4th. Again, you're multiplying your bases, so you're adding your powers. That's right. 3 plus the 4. And so I'm just going to try to drop it down here. We got a 7. And then my y's, I have a y, or just y to the 1. And then we got a y to the 12. Again, you're multiplying your bases, so then you're going to add your powers. And that's kind of your answer. Let me just make this look a little bit better. 20 x to the 7th, y to the 13. And yes, you have to type it just like that into the program to get it right. There we go. Cool. Okay. Number 9, here we go. Pretty big looking problem. Kind of crazy looking. It's very similar to the last problem in just that we're not multiplying, we're dividing. But you can see I'm already going to use a different color here. I want to break this down into like terms. So I have my x's together, my y's together, and then I got my numbers together. And so each one of these has its own like mini answer. And so I'm just focused right here, What's -15 divided by 5? Well, it's a -3. So that's easy. Okay, here, because they're both, I guess, like simplified, I guess you could say, there's no negatives flying around. All you really need to do here is subtract these numbers because you're dividing. You're going to subtract them. So there are times when it's appropriate to use the subtraction. It makes it a little bit quicker and easier. You don't want to have to flip it and then you got a negative and then you have to keep writing it. Just, this is easy. And the same thing here. And so I got 6, and then it would be a -4. And so combining all this stuff together, we actually get there a 9, x to the 9, and then we got a y to the 2. And that's your answer, just the way you see it. Type that in, and you're done. Okay, and the last problem, number 10. So this one is just like the last problem we did, but then they said, oh, wait, let's go ahead and put a power up here. Whoa. Yeah, it's pretty big. But so what I want to do is work from the inside out. I want to work on the inside part that I'm now familiar with. So I want to break this down here first, and then I'll work on that third power. And so, piece by piece, here we go. I got negative 24 over the 8 should be a negative 3. Okay. I'm just going to verify. I know we already know. I already know, but I'm just going to verify in the calculator. Yep, it's a negative 3. We're good. It's okay to use your calculator. It's okay. All right. So when I'm subtracting these here, I get something that's a little weird. And so I got A3 minus 10. Kind of different. We'll talk about that here in a second. Just let him go for a minute. He's okay. And I want to subtract. I guess you could flip it. There's a couple ways you could do this one. I'm going to go ahead and subtract here because we're trying to be consistent, I suppose. And of course, you got to remember your third power. Okay, so let's simplify a little bit here. What we have is a to the negative 7, and then we have a b to the, well, 2 negatives make a positive. So you're actually adding these numbers together to make the 15. There you go. Okay, cool. I'm going to just keep on cruising. I'm just going to keep on going. If you kind of know how this problem works, or if you've seen it before, there's an issue that's going to come up. I'm just going to ignore it for now, okay? In a good way. So the 3 power applies to every component. Look, I even zoomed in for you. Wow. That was just a mistake, sorry. And so, yeah, the 3 power applies even to the negative sign here. And so I've got 3 negatives, 2 cancel, 1's left behind. 3 to the 3, okay? I got a negative 7 to the 3 power. And then I've got b to the 15 all to the 3 power. Everything gets the 3 power. Now, I already did the minus sign simplification. So that's easy. But 3 to the 3, that's a 27. Powers of powers, they multiply. Very good. And so you actually get a negative 21. And then finally, 15 times 3 is a 45. That looks pretty bad. It's a big old problem. And this is correct. But when you type it into the program, they're not going to like it. Because, again, they're going to say, blah, 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 positive exponents. What do they mean by that? What is the problem here? Well, notice, is that right there? Is that positive? Is that exponent? Is that positive? No, it's a negative number. What we need to do is flip it into the denominator to make it a positive. And so my final answer is actually going to look like negative 27. And then I need to flip this guy. So I'm just going to flip him kind of like that. And then I have my regular old b to the 45. Does everything have a positive exponent? Yes. But it looks junky. So what I would like to do is make it all one fraction. Make it look a little bit better. There you go. That's your final answer. Now we're finally done. There we go. Now, I'm going to pause for a second. I did not do every problem on your homework. I did not. I'm specifically doing that because I want you to explore on some of the problems that I missed, that I skipped. And some of the ones that I skipped are repetitive and easy. Some have a special thing that maybe I just wanted you to figure it out on your own. In particular, like the next problem after this one on your homework, it's a funny little trick. It's just funny. So don't overthink anything. Use the tools that we've already used along the way. And so if you don't understand a problem, if you don't understand a format, get it wrong 3 times, go back and check, see what they have. That way you can at least see what they're wanting from you. And then you can go and, attempt it again with different numbers. You can always ask me if you have any questions, of course. I'm totally okay with that. But also just use the tools that we have from previous examples, previous problems. Like we were doing this problem here, which is, pretty bad. But it's just the same as this problem here, but with just a little extra. So I was doing the same process I did previously, and then I go and apply the next portion to it. Okay, so there's always a step process to these. And that's all I got. So, thank you very much, and have a great day.